Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani from Department of Computer Science, Aryabhat College, University of Delhi. So presently in this series of Introduction to Programming using C++, we are learning the topic function overloading, and in today's lecture we are going to see examples of ambiguities caused in function overloading. So just to build a platform, that in the previous lectures we have seen what actually function overloading is, then we have gone through in detail about the constructor overloading, and we have seen couple of reasons of ambiguity. So one reason, let me recall it in a nutshell, that one reasons of ambiguity in the overloading is having only different return types, not the different parameter list, neither in terms of numbers nor in terms of data types. That's going to cause an ambiguity for the compiler. And another reason which we have seen in the previous lecture was about the automatic type conversion. So automatic type conversion is one reason which is going to give us the which is going to generate an ambiguity. So continuing with that, we are going to use or we are going to see into one more example where ambiguity can be caused. So in order to understand that example, let us try to see how we can use it inside a program. So in a program, as you can see on the screen, we have hash include, iostream and namespace standard, those two standard things. And now we are having prototype of two functions, and these functions are overloaded with same return type, that is character. So character my func, unsigned character ch. So one is having an unsigned character and another one is having a signed character. So the name is similar, the return type is similar, and the only difference is unsigned character, one is having parameter unsigned character, another function is having parameter signed character. So what these functions are doing, for calling these functions inside the main function, let us see what these functions are doing. So basically by now you must have understood that this is actually a overloaded function in the name of myfunc. So wherever we have passed an unsigned character, this is going to return the previous value, in the sense I am saying character -1, and wherever we have passed only character, it is going to return the successor value of that character, or we can say ch plus 1. So there is a slight difference in the return value, or we can say there is a slight difference in the functionality. One is returning the previous character, another one is returning the next character, just by we can say implementing operation of minus and plus respectively. Now with the definition of these two functions and the prototypes written before the main, within the main I am calling one function as my function and the bracket I am saying C. So and for another I am going to call my function 88. So within this call, you can say the first call, which is my func bracket, within the bracket we have C as the character. This is going to call the simple my func character function, but whenever I am passing a number, let's say 88 or 66, whatever, this is going to give rise to an ambiguity, because here your compiler is confused. So if you are passing a simple character, this is going to call the character version. If you are going to pass a number, this is going to introduce an ambiguity, while let's see, and then the program is being terminated with a return 0. But at the pretext of this unsigned character and character, this actually kind of we can say this program will have problems in compilation. Now why? In C++, the unsigned characters and character are not, we can say, kind of having a very like water type compartment, or we can say these are not inherent inherently ambiguous. When my function is called using the integer 88, the compiler does not know which function is to be called. So either the function with a character value is to be called, or the function with an unsigned characters to be called. So should 88 be converted into a character, or should 88 be converted into an unsigned character? That is the ambiguity for the compiler, and in the scenario of this ambiguity, your compiler will not be able to take a decision that which version is to be called, and hence it is going to give error, because just because of the thing that unsigned character and character, specifically in C++, they are not inherently ambiguous. They cause ambiguity somewhere somehow. Now till this point, whatever ambiguity reasons we have seen, I am just recapping those reasons in short. That one is kind of having only just different return types, not having the difference in parameter list. Then implicit conversions, and those implicit conversions we have seen two examples. Now coming to the next cause of ambiguity is by using default argument. So if you can remember, in the previous lectures we have seen default arguments are, we can say, kind of a shortcut idea. In some situations they can be used as shortcut ideas, shortcut method or shortcut way to implement your function overloading. But again, we have to be very careful with default arguments, because they give rise to ambiguities as well. It is not just the kind of the shortcut which we are getting with default arguments. It is we need to be more cautious in using default arguments while overloading. So what kind of ambiguity these default arguments will introduce? Let's see them with the help of an example. So here I am having again the same name, the same return type, two overloaded functions. One is integer I, another one is having the parameter integer I and j is equals to 1. So my func is having one parameter, only one parameter, which is of type integer I. Another one is having two parameters, one is integer and I, and another one a default argument, where the default argument is is passed as j is equals to 1. Now let us see the definition of these functions first, and then we will come back to the call inside the main function. So the function which is having only one type is returning that integer as it is, and the my function which is having two parameters, one is I, another one is j, although that j is a default parameters, is returning a multiplication of I and j. So with these definition, let's try to see how the program will, whether it will work or will it not work when we are using these inside the main function. So in the main function, I have given two calls to this my func. So one call says my func 4 comma 5, so now, and another call says my func 10. So what is happening here with these two calls? Whenever I am saying my func 4 comma 5, the call is kind of very much, say we can say, clear, and it is an unambiguous call. That means it is going to call the function with two parameters I and j, although the j is a default parameter, but these default parameter will be replaced by the new value which is being passed in the parameter list, that is 4. So I will take place as 4 and j will take place as 5. So here there is no confusion to the compiler, and compiler is kind of very clear that which function is to be called. But when we are saying my func 10, this is actually a kind of, we can say, ambiguous call, because now the compiler is confused that which function is to be called, whether this is the kind of a call with only one parameter, or whether this is a call with one parameter and another parameter as default, which is int j equals to 1. So this is going to give rise to an ambiguity, and finally your program in the code is actually ending with a return 0. But with this ambiguity, when the second call to my function is made, ambiguity is occurring because compiler is not aware of that whether to call the version of my function that takes one argument or to apply the default argument to the version that takes two arguments. So in this case of this is actually an ambiguity, and then this is going to give us an error in compilation. Now if we are coming about if we are coming to see what kind of overloaded functions are ambiguous and what kind of overloaded functions are not ambiguous, we have to practice actually caution, or we have to practice this overloading very cautiously, because some types of overloaded functions are simply inherently ambiguous even if at first they may not seem so. So the program in the first glance looks like that everything is fine and everything is perfect and this will compile, there is no ambiguity. But if we are talking about overloaded functions, we have to be careful that these overloaded functions, some type of overloaded functions, not all obviously, some type of these overloaded functions are simply inherently ambiguous. Now let's try to see one of such example which seems ambiguous or it is not ambiguous, or maybe vice versa, which seems unambiguous but it is ambiguous. Let's see. So we have hash include iostream and using namespace standard. There is a function named as function f and having two versions of so basically an overloaded function I am talking about, with return types as void, and one function is having a value integer x and another function is being passed with a value integer %x. So %, as you all aware that whenever we are introducing %, that means we are talking about reference parameter. So here one parameter you can say is just a call by value parameter, another parameter is actually a call by reference parameter. Now coming to the definitions. So within the definitions we can say we are actually trying to figure out just with the help of an cout statement. So the definition of the function with integer x will print in f of the x, that's it, and within the kind of integer %x it is going to print in f and integer %. So one is printing the value as in call by value, another one is printing the value as in call by reference. So both are actually printing the value, but how are these being called inside the main function? Let's see, and whether this is going to get the compilation done or it is generating an error, that also we need to figure out. So here inside the main function, if I am going to say that integer a is equals to 10, and I am just without making kind of two different calls to these two overloaded functions, I am just asking f of a. So calling this f with a is going to an error because here your compiler is actually confused that which particular a we need to call, which particular version of the f function is needed to be called, and function is actually as usual ending with a return 0. Now actually what is happening here? So two functions, whenever we are overloading them, cannot be overloaded when there is only one difference, that is one is taking a reference parameter and another one is taking a call by value parameter. If there is a difference of only the parameters as in call by value and call by reference, then these functions cannot be overloaded Why? Because in these type of situation, your compiler has no way of knowing which version of the function is intended when it is called, because while calling, if you can see on the screen, we are saying just f of a. So whether f of integer x has been called or f of integer %x, that means whether we are referring to the call by value version or we are referring to the call by reference version, that is not clear to the compiler. So here compiler has no way of calling, no way of becoming aware, or no way of knowing which version you are actually referring to. So then obviously for compiler it is an ambiguity, so that's why this program is going to give you some errors. Also, we need to be very sure that there is no syntactical difference in the way that an argument is specified when it will be received by a reference parameter or by value parameter. So why this ambiguity is actually being introduced here in case of an call by value or a call by reference parameter? Because while calling, we will just say f and the parameter within the bracket, for example f of a. We are not specifying here f of %a separately. So there is no syntactical difference when we are calling the function or when we are specifying the argument. When it will be received by a reference parameter or by a value parameter, it is not specified when this argument is being returned inside the function. It is just returned as f of a. It is not returned as f of %a or f of asterisk of a. So here in C++, there is no syntactical difference in the way that an argument is specified when it will be received by a reference parameter or by a value parameter. So that that syntactically I can say uniformity is actually causing an ambiguity for the compiler, and hence that program will not be compiled. So now if we can see what all are the reasons till this point we have seen in which there is an ambiguity if we are talking about the overloading of functions. So overloading of functions is kind of a, we can say, very useful concept if we are talking about polymorphism, implementation of polymorphism in C++. But there can be ambiguities when, in order to list down these ambiguities in a nutshell, we can say one, when there is no difference in the parameter list, neither in terms of number nor in terms of we can say type of parameters, the only difference is the return type. Then your compiler is not going to compile and ambiguity will arise. Then the second situation comes up that we need to be very careful when we are talking about implicit type conversions. So implicit type conversions, we have seen two examples of those implicit type conversions. The one with the character and unsigned character, which are not inherently unambiguous, so there is an ambiguity. Another one, whether the integer will be promoted to float or the double version will be called, that was another example which we have seen in case of automatic type conversion, we can say. Another and the last reason which we cited is call by value and call by parameters, because there is no syntactical difference in the specification of arguments, that whether it will be received by a reference parameter or by a value parameter, this is going to give us the ambiguity, and hence the program will not compile. So till this point we have listed not, I cannot say all, but yes, many of the common reasons where ambiguity is to be arised when we are talking about overloading functions. So with all these nitty-gritties of function overloading, now we also need to see that we have seen what actually function overloading is, constructor overloading we have seen, but why do we need that is fine, why do we need function overloading? So one reason is polymorphism is there, and we need to implement polymorphism, that is fine, but how are we going to actually use, or in what kinds of situations we are actually using this function overloading, that has to be kind of very carefully studied. So basically, if we can say, what are the advantages of function overloading? There are two advantages of function overloading. One is improved code readability, and another one is it allows code reusability also. So let us try to explore these two advantages, which are very common advantages when we talk about function overloading. So one is improved code readability. Improved code readability, that means let's try to take an example of sum. So I am having two functions named as sum with obviously let's say void return type. The parameter list is two are having one function is having two integers and another function is having let's say three integers, and one function is having only one integer as a parameter. So and we are with different numbers of parameters we can allow two integer numbers. For another version we can allow three integer numbers, and we can allow 4 or 5 arguments with the same name, or with the single argument we can just add it up to 0. So if we are passing only one argument, it will be added to 0 and the result will be same. If we are passing two arguments, the corresponding sum function will be invoked and the sum of two arguments will be returned or printed. Then if we are talking about let's say three arguments, those three integers will be summed. So that is, we can say, it is actually increasing the code readability, in the sense user who is reading, or programmer who is taking your code will understand that this is the sum for one parameter, this is the sum for two parameters, this is the sum for three parameters, and you are actually increasing the readability of the code, because your we can say the implementation details are same, only the number of parameters is different. Now imagine a scenario when you don't have any facility like function overloading. What will happen? You will say sum 1 with one parameter, sum 2 with two parameters, and sum 3 with three parameters. So that means three different names for the same implementation or for the same working. The only difference is number of parameters. So you need to remember, or you need to take care of three different names. So that is actually going to give you less readability in terms of when we talk about whole throughout code, clean code we are talking about. Or we can say another advantage which is provided us with the help of function overloading is code reusability. So code reusability is basically what? Again I am taking the example of this sum function. So this sum function, I have taken passed two integers, and that sum function is kind of adding these two integers. And when we are saying that two characters or two strings have been passed as parameters, then that overloaded version of sum function is actually concatenating the two strings. So I mean it is a kind of reusability and readability both, that if we are passing two integers, those are added. If we are passing two strings, those strings are concatenated together. So if you are saying sum 3, 4, the answer is 7, and if you are saying sum within the brackets new and York, so it is going to give you a concatenation of the two, and the answer will be New York. So in this way we are actually kind of improving upon the code reusability and code readability both, which will actually kind of become very difficult if we don't have function overloading. So as I have told you that we need to name the functions as sum 0 or some integer, some character, or something of that sort. Now here the readability is improved because the name is same and it is going to give you the different implementation based on the number of parameters. So, we can say till this point where what we have seen function overloading, then we have also seen character constructor overloading and various nitty-gritties of function overloading, including the advantages and the reasons of ambiguities whenever the function overloading is done. And here is a list of references which is being used for while preparing this lecture. Hope you have enjoyed the lecture. Thank you for a patient hearing.